You know, usually when we talk about a scientific framework or even something like a medical diagnosis,
Mhm.
there's this really ingrained expectation of precision.
Oh,
It
yeah.
feels almost like engineering. If you break your arm, you go to the hospital, they take an x-ray, and you see that jagged white line right there on the film.
Exactly. It's right in front of you.
Yeah, the doctor just points to it and says, there it is. That's the problem.
It's a very binary experience. I mean, you look at the image, you see the structure, and it just perfectly maps onto your physical reality.
Right. Broken or not broken, it's clean, it's objective, and I think most importantly, it's physical. You can actually point to the thing.
And that is deeply comforting to the human mind.
Oh, absolutely.
We like things to be visible. We like things to be, categorized, boxed, and just neatly laid out on a table where we can see them.
But then you step away from that macroscopic world and you step into the world of theoretical physics.
Yeah, that's where it all changes.
It really does. You start digging into the deep foundational nature of our universe, like the stuff that makes up the bone, the atoms, the actual space between the atoms, and suddenly that X-ray machine is just, it's broken.
Completely useless.
Right. We find ourselves looking at a diagnostic landscape that is, honestly, it's incredibly murky because the thing you're trying to take a picture of might not actually be a thing at all. It might just be a shadow of something else entirely. And that realization is really what brings us to our deep dive for today.
That's a big one.
It is. So I want to welcome you to the conversation. Today, we're taking you on a journey that is going to require you to bend your mind a little bit.
Just a little.
Maybe a lot. Actually, I want you to imagine something that sounds seemingly impossible. I want you to imagine that a 2,400-year-old philosophical allegory, the famously unsolvable mathematical three-body problem, and the speculative engineering blueprints for aerospace tech like warp drives.
Right, the real fringe stuff.
Yeah, that all of these are at their core actually talking about the exact same thing.
I know it sounds like the setup to a sprawling science fiction novel or maybe some late-night dorm room speculation, but I promise you, we're looking at an intensely, rigorously mathematically grounded framework today.
We really are. Our source material for this deep dive is a stack of recent, incredibly dense theoretical physics papers authored by an independent researcher named John Surmont.
Yes.
The papers detail this comprehensive framework called the oscillatory dynamics transductive bridging theorem.
Which is quite a mouthful.
It really is. Or, because we'd rather not say that 10 times a minute, we'll just be referring to it simply as ODTBT.
Perfect.
So the mission for us today, and specifically for you as you listen, is to completely shift your paradigm. We're going to try to move your mind away from a universe made of, objects and trajectories.
Classical view.
Right. The idea of the universe as this giant pool table with billiard balls just bouncing around in empty space, we're leaving that completely behind. Instead, we are stepping into a universe made entirely of recursive oscillatory fields.
And I want to establish a baseline of reassurance right from the start here. The math in Surmont's papers is, well, it's undeniably complex.
Insanely complex.
Yeah, we're going to be talking about multidimensional geometries, nonlinear dynamics, and topological phase states.
Right.
But the underlying pattern beneath all that math is actually this beautiful, almost intuitive geometry. It's a framework that doesn't just arbitrarily tell us what reality looks like, but it actually provides a mathematical mechanism explaining why reality is forced to look the way it does.
Okay, let's unpack this. Because to even begin to understand this highly complex ODTBT framework, we actually need to start with something that might be surprisingly familiar to you.
Yeah, a classic.
Something you might have read in a freshman philosophy class or, seen referenced in a movie. I'm talking about Plato's allegory of the cave.
Right.
But we have to fundamentally reframe it. Surmont's paper, which is titled Shadows, Substrate, and the Speed of Light, makes this really bold claim. It argues that Plato's cave isn't just a neat metaphor for human ignorance versus enlightenment.
No, not at all.
It argues that the allegory is a mathematically precise description of the limits of modern physics.
Yes. What's fascinating here is that Surmont isn't just loosely borrowing the imagery, He establishes an exact one-to-one formal mathematical mapping between Plato's story and the geometry of our physical universe.
It's
Think about that for a second. Plato wrote this in roughly 380 BCE, obviously without the mathematical apparatus, the particle accelerators, or the telescopes we have today.
Right.
And yet structurally, he perfectly described the geometry of what ODTBT calls an observer-limited projection.
So to understand how this works, we really need to break down the elements of the cave, piece by piece, and translate them into physics.
Let's do it.
So just to refresh your memory, in the classic allegory, you have a group of prisoners, and they've been chained inside a dark cave for their entire lives. They're facing a blank stone wall. Crucially, they cannot turn their heads. They can only look forward.
Right there, locked in place.
Exactly. Behind them, in the distance, a massive fire is burning. And between that fire and the prisoners, there's a raised walkway where people are carrying various objects like statues, animal figures, things like that.
Yeah.
Because the fire is behind the objects, it casts shadows onto the wall that the prisoners are staring at. And because the prisoners have never seen anything else...
That's their whole world.
Right. They genuinely believe that those two-dimensional shadows dancing on the wall are the absolute totality of reality.
Right. To the prisoners, a shadow of a bird isn't a representation of a bird. It is the bird.
Exactly.
They measure the shadows, they watch how the shadows interact, they predict when a shadow will appear,
Yeah.
and they build entire rigorous sciences around the behavior of those shadows.
And according to ODTBT, that is exactly what we are doing.
It's precisely. Let's map the variables here. In ODTBT, the cave itself, the physical space the prisoners occupy, is our projected 3+1 dimensional spacetime. It's the 3 dimensions of space and 1 dimension of time that we experience every single day. Surmont's paper formally defines this as the observable layer, or O2.
Okay, so the universe we see is the cave. So what are the shadows?
The shadows on the wall are observable physical events.
Like what?
Well, when we run a particle accelerator and detect an electron, or when we measure a photon of light, or when we observe a gravitational pull, those are the shadows.
Wow.
Surmont terms these SEU commission patterns. Standard physics, meaning everything from Newton's laws to the standard model of particle physics to quantum mechanics, is what the paper refers to as shadow science.
Hold on, I need to jump in here. Because when you say shadow science, it sounds incredibly dismissive.
I know it does.
Like, it sounds like the paper is saying that all of modern physics, which gave us microchips and put rovers on Mars, is completely wrong.
Right, and that's a crucial point of clarification, and it's something the paper is very, very careful about. It does not say that standard physics is wrong. In fact, standard physics is extraordinarily precise. If you're a prisoner in the cave and you spend centuries measuring the exact speed and trajectory of a shadow on the wall, your predictions about where that shadow will be tomorrow are going to be 100% correct.
So the math works.
Yes, the prisoner's ability to predict the shadows is genuine knowledge. It works. The issue isn't that the science is wrong. The issue is that the science is incomplete.
I see.
It is a science of the projections. It describes the behavior of the shadows flawlessly, but it completely misses the source generating them.
So it's descriptive, not explanatory. We know exactly what the shadow does, but we have no idea what is actually casting it.
Exactly. Now, if we look outside the cave entirely, Plato talks about the sun.
Right, the outside world.
The sun is the ultimate source of reality, the true illumination outside the dark limits of the human condition. In ODTBT, the sun maps to what is called the scalar coherence substrate, denoted mathematically as palific.
Palific, got it.
This substrate is the ultimate fundamental field of reality. It's the source from which all observable structure in our universe emerges.
Okay.
The actual multidimensional objects that exist in this substrate, the things being carried on the walkway casting the shadows, are called full 5-dimensional coherent states.
Okay, I'm tracking with this. We live in the 3D projection, studying the shadows, and there are these 5D objects in the underlying substrate actually casting them.
Exactly.
But that brings us to the fire. The light source inside the cave that's actually doing the projecting, how does that map to physics?
This is where Surmont's paper makes one of its most stunning connections. The fire is the speed of light,
Wait,
represented by the constant c.
the speed of light is the fire,
Yes. And this requires a massive shift in how we think about c.
I'll say.
In standard physics, we're taught that the speed of light is a fundamental speed limit of the universe. Nothing can travel faster than roughly 300,000 kilometers per second.
Right, that's Physics 101.
But in the ODTBT framework, c is not a speed limit for objects traveling through space. Instead, it is the projection geometry's resolution rate.
I'm going to need an analogy for that. What is a resolution rate?
Well, let me put it this way. The equation derived in the framework for the speed of light is c equals 1 over the square root of epsilon rec times mu rec.
Okay.
In plain terms, c is the rate at which information from the higher dimensional substrate translates or resolves into our three-dimensional observable reality. It's the processing speed of the projection.
Okay, so it's like we've been living inside a massive, incredibly detailed multiplayer video game.
Yes.
And for centuries, we've been measuring the pixels on the screen with unbelievable accuracy. We know exactly how the pixels change color, we know how fast a pixel character can move from one side of the screen to the other, and we've written down all the rules they follow.
Right.
But we've never actually turned around to look at the graphics card that is generating the game or the code dictating the rendering engine. So when we measure the speed of light, we think we found the ultimate speed limit of the game's physical universe.
But really, you've just measured the frame rate of the monitor.
That is insane. Just the refresh rate.
It's a phenomenal way to conceptualize it. If the monitor has a refresh rate of 60 frames per second, no object inside the game can visually move faster than what that refresh rate can draw.
Right.
The speed of light dictates how fast coherence events occurring in the deep substrate can actually resolve into visible, measurable space-time reality. It is the fire casting the shadow.
That completely flips physics on its head, but it leaves one major element of the cave allegory unaccounted for.
By chains.
The chains. The prisoners are chained to the floor and physically cannot turn their heads to see the fire or the objects. So who put the chains on us?
The chains are a mathematical necessity of the observer. In ODTBT, the prisoners represent us, the observers. But we aren't chained by physical iron.
Right.
We are chained by what the paper calls ZDV lock conditions. ZDV stands for zero-dimensional vector.
What does that mean?
Basically, it means that in order for us to exist as stable, conscious entities capable of making an observation in this universe, our internal observer phase alignment must be locked into a specific frequency.
Oh, yeah.
We physically cannot turn our heads to see the five-dimensional reality because our active observation itself is phase-limited. We're tuned to a specific channel, and we can only see the data broadcast on that channel.
We are built out of the same shadows we are trying to observe, so we're inherently limited by our own composition.
Exactly.
But wait, if we are stuck in the cave and our math is just shadow math, how did we ever figure out the really deep stuff, like Einstein?
Right.
Einstein figured out E = mc squared. He showed that mass and energy are the same thing. How did he do that if he didn't have access to the graphics card?
If we connect this to the bigger picture, this is arguably one of the most profound realizations in Surmont's text. Einstein discovered the mass-energy equivalence entirely from inside the cave.
He never stepped out.
He never stepped outside. In the ODTBT framework, mass isn't a solid physical thing. Mass is simply locked coherence.
Locked coherence.
Yeah, it's the shadow of a stable, self-reinforcing topological structure in the substrate. Energy, on the other hand, is released coherence. When that stable topological structure unwinds or breaks, the coherence is released.
So mass is a frozen shadow, and energy is the shadow moving freely.
Exactly. And Einstein, sitting entirely inside the cave, realized that you can convert the locked shadow mass into the released shadow energy.
Okay.
And what mediates that conversion? The fire.
Oh, wow.
The resolution rate of the projection, which is why the equation is E = mc squared. The speed of light squared is the conversion factor.
That's incredible.
The prisoners deduced the exact mathematical relationship between the shadows without ever once looking at the sun. That is the triumph of human shadow science.
That gives me chills.
Oh.
We mapped the relationship with the shadows so accurately that we accidentally proved the existence of the fire projecting them, even though we couldn't see it. But in Plato's allegory, the story doesn't end with everyone staying in the dark. Eventually, someone gets out.
Right, the Ascent.
Yeah, a prisoner is unchained and physically dragged out of the cave up into the sunlight. And Plato goes out of his way to emphasize that this process is awful.
It's terrible.
It's confusing, it's disorienting, and the sunlight physically blinds the prisoner. It's a painful ascent.
Yes, the Ascent is not a gentle realization. It is violent. In the ODTBT framework, this ascent is mathematically formalized as the twist bifurcation.
Twist?
Right. TWIST is an acronym that stands for Threshold Waveform Interaction for State Transformation.
Okay, what does that actually look like? If I am a holonic oscillator, like if I am a node in this field, how do I twist?
It is a discontinuous, irreversible phase transition. Imagine you're putting tension on a rubber band. You stretch it, and it holds its shape.
Right.
But eventually, the strain becomes too much. It doesn't just slowly become a different shape. It snaps violently and reorganizes.
Oh, I see.
In ODTBT, when the accumulated phase strain of a system reaches a critical mathematical threshold, the system doesn't just gradually improve its resolution. It violently reorganizes into a new, higher phase alignment.
So the chains break.
Exactly.
Hmm.
The observer's accessible dimensions suddenly expand. It's painful, conceptually speaking, because the moment that bifurcation happens, all of the old shadow reading skill,
Everything you knew.
yeah, the entire conceptual framework of the cave, all the classical physics you relied on, suddenly become completely useless in the face of the new, higher attractors geometry. You are forced to operate on a fundamentally different geometric plane.
Here's where it gets really interesting. Because Surmont's papers don't just leave us sitting in the cave theorizing about the sunlight.
No, they go all the way.
The papers actually attempt to build out the precise mathematics of what is outside. A few moments ago, we talked about the objects casting the shadows as being five-dimensional coherent states. But as we move into the deeper sections of the material, specifically a section referred to as Addendum 21, the text reveals that the true graphics card-like, the ultimate reality generating the simulation, isn't five-dimensional at all.
Not even close.
It is a staggering 12-dimensional fiber bundle called S12.
That's right. The five-dimensional geometric bulk, which Surmont calls S5, is merely the observable face of this vastly larger 12-dimensional state.
Okay.
The 5D objects are just the components that interface with the fire to cast the shadow. But to understand the true source, you need all 12 dimensions. The paper meticulously breaks down this architecture.
We should walk through it.
Let's walk through it because it is essentially the blueprint of the universe.
I'm ready. Let's build a universe. Where do we start?
We start with the foundation, the 5D geometric bulk. These 5 dimensions handle the primary relational mechanic between interacting fields.
Okay.
They contain phase strain, which is the tension between two interacting partners. They contain RCR, which stands for recursive coherence memory.
Wait, memory. What does it mean for a physical field to have memory? I mean, space isn't a hard drive.
In a field-based universe, memory isn't stored data like on a computer. Memory is topology.
Topology.
Think of a piece of paper. If you fold it in half and then unfold it, the crease remains.
Oh, right.
The paper remembers the fold because its geometric structure has been permanently altered. In ODTBT, RCR is a topological crease left in the substrate when fields interact. The field retains the imprint of past phase interactions.
That makes perfect sense.
And finally, the 5D bulk includes recursion depth, denoted as N. This simply measures how many times a field has folded back in on itself, nesting like Russian dolls.
Okay, I can visualize that. Tension, topological memory, and nesting dolls. That's 5 dimensions. Yeah. But we are aiming for 12. What's next?
Next, we add the SU2 Spinor fiber. This adds 3 highly specific dimensions that deal purely with how the system handles branching. Imagine a river splitting into 2 streams. The Spinor fiber governs symmetric phase exchange, how the 2 streams balance each other. It governs phase circulation, which is what gives us helical, twisting structures in particle physics. And it governs phase asymmetry.
Why do we need a separate mathematical fiber just for that?
Because these 3 dimensions are entirely invisible if you are only looking at a simple, single, isolated wave.
Oh.
If a wave isn't interacting with anything, what the text calls a singlet channel, these dimensions basically remain dormant. They only activate, they only turn on mathematically when a system splits into a complex triplet configuration and needs to mathematically distinguish between its interaction partners.
Fascinating. It's like extra processing power that only kicks in when the physics gets complicated.
Exactly.
Okay, so 5 bulk dimensions plus 3 Spinor dimensions. We are at 8. Where are the final 4?
The final 4 dimensions make up the substrate layer itself. This is the deepest level of the reality code. Dimension 9 is omega, which is the observer phase alignment.
That's the chains.
Yes. The very act of observing is physically written into the fundamental geometry of the universe.
Unbelievable.
Dimension 10 is torsion memory potential, FIM, which deals with rotational memory. Dimension 11 is incredibly important. It is the lock potential, lambda.
And what does that do?
This is the geometric mechanism that literally generates mass. Mass is born in dimension 11.
Wow.
And finally, dimension 12 is the coherence gradient across recursion depth, CG. This ensures that as things nest deeper and deeper, they remain mathematically connected to the whole.
Okay.
12 independent coordinates. That is what is mathematically required to fully specify the state of reality before a twist bifurcation resets the system.
I am trying to picture a 12-dimensional object in my head, and my brain is just flatlining.
It's completely normal.
But apparently, I'm not the only one who struggled with this, because the text details a massive and, quite frankly, beautifully instructive failure during the development of this theory.
Yes, phase 2.
Surmont describes this period he calls Phase 2. His team generated 136 different mathematical models, geometric candidates, for what this multidimensional structure might look like.
Right.
And they decided to test these 136 models against the real world. They took 16 known fundamental physical constants published by the National Institute of Standards and Technology.
Yes.
Things like the fine structure constant, the mass ratio of the proton to the electron, the hardest, most precise numbers in all of shadow science.
The gold standard.
Exactly. They ran a blind comparison, expecting the true 12-dimensional geometry to perfectly output these 16 constants. And what happened? Out of 136 candidates, they found exactly 0 natural matches.
None.
It was a completely null result.
It was total wipeout. And in standard academic science, a result like that is usually fatal. Most researchers would throw the theory in the trash, assume their foundational hypothesis was wrong, and start over from scratch.
But Surmont didn't.
No. What's fascinating here is that Surmont realized this wasn't a mathematical failure at all. It was a structural finding. He stepped back and realized they were making a fundamental categorical error. He called it the shadow grammar mistake.
What does that mean, shadow grammar?
Well, they were taking real numbers, the physical constants we measure with our instruments here inside the cave, and they were trying to match them directly against the pure geometric coordinates of the 12-dimensional substrate.
Right.
But Surmont realized that the constants we measure aren't the actual substrate coordinates. They are the projections of those coordinates onto our wall.
Ah.
As he brilliantly puts it in the text, you cannot take the two-dimensional shadow of a human hand, compare it to the two-dimensional shadow of a book, and expect to derive the geometric laws of three-dimensional volume.
Because the shadow loses data.
Exactly.
It's like taking a beautifully complex 3D architectural rendering of a skyscraper, shining a flashlight on it, and tracing its outline on a piece of paper.
Yes.
The outline is accurate, but it has 0 depth. And Surmont's team was trying to use those flat, depthless outlines to figure out how the plumbing worked on the 50th floor.
That is exactly it. The constants we measure in the lab, like the fine structure constant, do not live on a simple, flat, real number Euclidean axis. They live in the substrates phase geometry.
Okay.
The numbers we measure are literally just the sine and cosine projections, the trigonometric shadows of those higher dimensional angles. Once they corrected the grammar and applied the proper trigonometric projection filters, the math aligned.
And this realization, this correction of the shadow grammar, doesn't just fix a math error. It actually solves one of the most glaring, stubborn mysteries in all of modern particle physics, a mystery known as the rule of 3.
Yes, the standard model of particle physics is inexplicably obsessed with the number 3.
It really is.
We have 3 generations of fermions, like the electron, the muon, and the tau particle. We have 3 fundamental forces operating at the quantum level: electromagnetism, the strong nuclear force, and the weak nuclear force. Quarks come in 3 colors.
Right. And if you ask a physicist why there are exactly 3 generations of matter, they usually just shrug.
Because they don't know.
The math works, the experiments confirm it, but the underlying reason for the triad is a total blank spot.
Well, under the S12 framework, the mystery vanishes, because the triadic structure is revealed to be an optical illusion caused by the projection.
Wait, really?
Yes. The underlying substrate actually has a quadratic or 4-node structure. It was fundamentally built on 4s, not 3s.
How does a universe built on 4s cast a shadow built on 3s?
Think about the observer's chains again. When you project a 4-node, 12-dimensional system through the phase-limited lens of a ZDV-locked observer down into 2 observable dimensions,
Okay.
one of the nodes gets structurally occluded. The 4th node, which represents the field itself, the transductive source, remains entirely hidden in the blind spot of the projection. We simply do not have the phase alignment to see it.
So a quadratic reality casts a triadic shadow. We see 3 points of a square and assume the universe is a triangle.
Exactly. The standard model has 19 free parameters numbers that have to be plugged in by hand because the theory can't explain where they come from. In ODTBT, those 19 parameters aren't arbitrary variables. They are precisely what the 12 substrate coordinates look like when dimensions 7 through 12 are collapsed out of view by the observer's limitations.
So the standard model is the most accurate 2D floor plan ever drawn, but ODTBT is the 3D rendering of the entire building.
Yes.
And speaking of the shape of the building, there is a very specific geometric shape that keeps popping up in the papers.
The icosahedron.
Right. It states that the fundamental topological lock condition, the θ60, naturally generates icosahedral symmetry,
Yeah.
the 20-sided shape like a tabletop role-playing die, and because of that shape, the math repeatedly spits out a very famous number, the golden ratio.
Yeah.
Roughly 1.618.
We see it everywhere.
We see this number in biology all the time. The arrangement of seeds in a sunflower, the spiral of a nautilus shell, the shape of galaxies. Usually scientists just treat it as a neat mathematical curiosity of emergent complex systems. But Surmont says it's much deeper than that.
He argues it is not a biological coincidence. It is a foundational, structural inevitability of physics.
How?
Because the fundamental lock potential of reality requires icosahedral geometry to stabilize. And because the golden ratio is mathematically intrinsic to the vertex coordinates of any icosahedron, the universe has no choice.
It's baked in.
Completely. When the universe nests its recursive layers, when it builds structures inside of structures, from subatomic fields up to galaxies, it must scale those layers by the golden ratio. The substrate itself is woven with phi.
Okay, so we have built this absolutely gorgeous 12-dimensional golden ratio-infused structure.
Look beautiful.
It's elegant, it is theoretically satisfying, but theoretical beauty doesn't mean anything if it doesn't match the dirt and grit of reality.
No, it doesn't.
How do we actually prove this works? If I'm a skeptical physicist, I want to know, how does this 12-dimensional architecture mathematically prove anything about the actual physical particles we measure in a particle accelerator?
Right.
This leads us into an incredibly dense part of the research, Addendum 22.9, which sets out to calculate the actual mass ratios of real particles.
This is where the framework leaves the realm of philosophy and enters the realm of hard empirical calculation.
Okay.
To calculate particle masses, Surmont relies on what he calls a dual formula architecture. He realized that if particles are just localized phase locks in a field, then the mathematics used to describe their geometry must perfectly reflect their structural nature.
Makes sense.
Not all particles are built the same way, so you can't use the same formula to describe their shadow.
Give me an example. How does a particle differ?
Let's look at two classes of particles, leptons and mesons. Leptons, like the muon and the tau particle, are considered elementary. As far as we know, they're not made up of any smaller pieces.
Okay, they're fundamental.
Right. Because they're elementary, their recursive oscillatory streams originate in the exact same fundamental phase space. They're folding in on themselves.
Okay.
Therefore, to calculate their mass, you must use the full, highly complex 6-parameter formula, which ODTBT calls the RCM He V2 poly triplet. You need all that mathematical machinery to account for their intense self-interaction.
Okay, that makes sense. A single complex knot needs a complex formula. What about mesons?
The mesons, like the neutral kaon or the charged pions, are composite particles. They are made up of a quark and an antiquark.
Right.
Because they're composite, their two recursive streams do not originate from the same space. They originate from distinct, separated constituent parts. They aren't deeply self-interacting in the same way.
I see.
Therefore, you do not use the heavy polytriplet formula. You use a much simpler 4-parameter equation based on the geometric mean of independent scalar locks.
And does the math actually care about this distinction? Like, does it punish you if you use the wrong formula?
Brutally. And this is how they prove the architecture. The text notes that when the researchers intentionally, or perhaps initially accidentally, applied the simpler meson formula to calculate the mass of the elementary muon particle, the result was a 2087% error.
Whoa.
It wasn't even in the right ballpark. It was a complete mathematical failure.
But when they applied the correct lepton formula,
The error rate plummeted to 0.032%.
that is an astonishing level of accuracy. 0.032% error just by matching the correct topological geometry to the particle type.
Exactly.
But I was reading the formulas and I noticed a common denominator. In order to get these highly accurate mass ratios, every single particle's calculation is divided by something called the electron baseline.
Yes.
The framework sets the electron at a recursion depth of n equals 3. That specific depth seems to be the anchor for the entire universe's mass. Why depth 3? Why not 1 or 100?
This brings us to what is arguably the most mysterious, almost magical finding in the entire framework. It's referred to as the near 3 pi coincidence.
Okay.
To understand why depth 3 is so critical, we have to look at the formula for the scalar lock potential. This formula contains a frequency modulation parameter, which is multiplied by the electron's specific phase strain.
Right.
The mathematical value of that phase strain is the fraction 175 over 24.
Okay, I'm following.
When you plug in a recursion depth of 3, the formula requires you to multiply 1.3 times 175 over 24. If you simplify that math, you get the fraction 455 over 48.
I actually paused my reading and typed that into a calculator.
455 divided by 48 gives you a decimal of roughly 9.4792.
Right. Keep that number in your head. 9.4792. Now I want you to calculate the value of 3 pi, 3 times the constant pi.
Okay, pi is roughly 3.14159. Multiply by 3, you get roughly 9.4248.
Look at those two numbers, 9.4792 and 9.4248.
They're incredibly close.
At recursion depth 3, the geometric value generated by the phase strain is incredibly, almost suspiciously close to a perfect multiple of pi. The deviation is only about 0.054 radians.
Wow.
Now, this might just seem like a neat bit of numerology, but in wave mechanics, being close to a multiple of chi has massive physical consequences because this number is processed through a sine function.
Okay.
And what is the sign of a number that is very close to 3 pi?
Well, the sign of any multiple of pi is 0, so the sign of a number near 3 pi must be near 0.
Exactly. Specifically, the sign value evaluates to roughly 0.054. It is a tiny, tiny number.
Okay, I see the math. The sign value at depth 3 is tiny, but why on earth is a tiny sign value the secret to unlocking the mass of the universe? If we connect this to the bigger picture, it is all about what Surmont calls the global consistency mechanism.
Okay.
The mathematical function that dictates the scalar lock potential, which is the direct source of mass, has an absolute hard mathematical ceiling. Its value cannot mathematically exceed 1.0. It's a hard limit.
Understood.
Now, remember that in this framework, we aren't calculating absolute weights in kilograms. We are calculating mass ratios. Every other particle in the universe is calculated as a ratio against the electron's baseline lock potential.
Oh, I think I see it. The proton, for example, is famous for being roughly 1,836 times heavier than the electron.
Precisely. Now, imagine if the electron's baseline lock potential wasn't near 0. Imagine if it was a relatively large number, say 0.1.
Do I?
If you take an electron baseline of 0.1 and you have to multiply it by 1836 to scale up to the mass of a proton, you would end up with a proton lock potential of 183.6.
Which completely shatters the mathematical ceiling of 1.0.
Yes.
The equation would break. The proton literally could not exist within the geometry.
Exactly. But because the electron sits precisely at recursion depth 3, where the 3 pi coincidence generates that tiny near-zero sign value, the electron baseline is uniquely microscopic.
Wow.
The text notes it's between 7 to 47 times smaller than the baseline at any other integer depth. This tiny denominator acts as a massive mathematical shock absorber.
A shock absorber.
Yeah. It provides enough numerical room beneath the ceiling of 1.0 for the heavy particles, the protons, the neutrons, the massive bosons, to achieve their massive scale without violating the fundamental limits of the field potential. The electron's tiny mass is what allows the rest of the heavy universe to exist.
That is breathtaking. It's like the universe threaded a mathematical needle so that we could have both lightweight electricity and heavy atoms existing in the same reality.
Yes.
And the results of this calculation are undeniable. Using the single 3 pi driven baseline, the ODTBT framework perfectly predicts the mass ratios of 9 out of the 10 fundamental particles tested in the published corpus.
It does.
And it does it with sub% error rates. And, crucially, it does this with 0 continuous free parameters. There's no fudging the numbers. It's pure integer-based geometry.
Yes. It is a stunning validation of the geometry.
Though, as the proxy for the skeptical listener, I have to ask, you said it predicts 9 out of 10 particles. What is the deal with the 10th particle? Did the math finally break?
The 10th particle is the neutral pion, denoted as pion. And yes, it remains an open case.
Right.
The framework has not yet found a theoretical, geometrically motivated justification for its specific configuration. It doesn't quite fit the dual formulas perfectly. It is the one glaring outlier.
Doesn't that worry you? A unified theory needs to unify everything.
Honestly, it adds a strange layer of credibility to the paper.
How so?
Well, in theoretical physics, when someone develops a new theory of everything, there is immense pressure to force the data to fit. A less rigorous researcher might have fudged a parameter or invented a new, completely arbitrary rule just for the neutral pion to make the spreadsheet look perfect.
Just to smooth it over.
Exactly. But Surmont doesn't do that. He explicitly acknowledges the pi anomaly as an open question pending further theoretical motivation. It's intellectually honest.
I love that approach. We solved 90% of the puzzle, but we aren't going to jam this last piece in with a hammer. We'll leave it on the table until we understand the shape of the whole.
Right.
But I need to push back on the core mechanism here, this 3 pi coincidence. Is the fact that 455 over 48 happens to be so close to 3 pi just a crazy numerical fluke, like a cosmic accident of the math? Or is it a fundamental, purposeful law of the integer lattice?
This raises an important question, and it's one the paper actively grapples with. Surmont classifies this coincidence under what he calls mechanism E in his Diophantine classification.
What is Diophantine classification?
The Diophantine approximation is a branch of number theory that studies how well real numbers, like the irrational number pi, can be approximated by rational numbers, which are simple fractions.
Ah,
Surmont explicitly leaves the philosophical nature of this coincidence open. He states that whether this is a fortuitous numerical accident or whether it reflects a deeper, undiscovered Diophantine structure, a fundamental geometric property of the integer lattice itself remains unknown.
so it's still a bit of a mystery.
It borders on number theory magic. But here's the critical takeaway. Physically, practically, regardless of why the coincidence exists, the empirical consequence is mathematically undeniable.
Right.
The near 3 pi value functions as the global consistency mechanism that stabilizes the mass ratios of our universe.
Okay, so we've established that ODTBT has seemingly cracked the code on subatomic particle masses by treating them as oscillatory fields rather than hard physical objects.
Yes.
It works beautifully on the microscopic scale. But if this field-based view is truly universal, it can't just explain the very small. It has to explain the unimaginably large.
It does.
Can it solve macroscopic mysteries? And that brings us to one of the most infamous, historically unsolvable puzzles in the history of physics, the three-body problem.
Oh, the three-body problem is the quintessential nightmare of standard classical mechanics.
It really is.
It is the classic example of deterministic chaos. Since Isaac Newton formulated the laws of gravity, we have known how to perfectly calculate the orbital dance of two bodies interacting gravitationally.
Sure.
If you have the Earth and the Moon alone in a void, their orbits are elegant, predictable, and mathematically flawless. It's celestial clockwork.
Right. You can predict exactly where the moon will be a million years from now. But
the exact moment you introduce a third mass into the equation, say you add the sun to the Earth-Moon system,
yeah,
the classical math completely collapses.
just fall apart.
The gravitational feedback loops between the three bodies become infinitely complex. The equations become chaotic, nonlinear, and infinitely sensitive to the tiniest initial conditions.
Right.
Despite centuries of effort by the greatest mathematicians in history, classical physics simply cannot solve the three-body problem in a universal, closed-form equation. It is mathematically intractable.
And according to ODTBT, it's intractable because it's an object-based physics failure. We are trying to track three specific billiard balls rolling on a rubber sheet that is constantly warping beneath them.
Exactly.
But ODTBT looks at that problem and says, you're failing because you're still looking at the balls.
Exactly. Surmont argues that our failure to solve the three-body problem isn't due to a lack of computational power, and it isn't because the universe is inherently random. Our failure is due to an ontological mismatch.
Meaning we are fundamentally misunderstanding what a planet actually is.
Precisely. We are trying to use object-based math tracking rigid trajectories and point masses moving through a passive Euclidean space to solve what is fundamentally an oscillatory phase problem.
So in this 12-dimensional framework, what is a planet? If Jupiter isn't a giant ball of gas moving through empty space, what is it? The text refers to massive bodies as holonic oscillators. What does that mean for the listener trying to visualize this?
A holon is a philosophical concept of something that is simultaneously a whole, complete entity in itself, but also just a fractional part of a much larger system.
Okay.
In ODTBT, a planet or a star is not a solid object interacting with other solid objects via invisible magical strings called gravity. A planet is a localized compression node within a unified transductive field.
I need a physical analogy for that.
Imagine a massive bathtub filled with water. Now imagine three distinct, complex ripple patterns moving across the surface.
Okay, I can picture that.
Classical physics tries to define those ripples as objects and tries to predict exactly where they will bounce off each other. It's chaotic. ODTBT says, don't look at the ripples, look at the water.
Wow.
The ripples aren't objects, they're just localized areas of tension in the medium itself. The planets are localized points of locked phase coherence. They don't push and pull each other through an empty void. They interact through recursive phase entrainment.
So their oscillations sync up or clash based on the resonance of the entire bathtub field.
Exactly. They're constantly communicating their phase state to the entire field, and the field dictates their motion.
But wait, I have to stop you. If planets are just oscillating fields in a bathtub, what happens to chaos theory?
Ah,
We've all seen those mesmerizing computer simulations of the three-body problem, where the three stars orbit each other nicely for a while, and then suddenly, seemingly randomly, one of the stars just gets violently flung out into deep space.
yes.
The system falls into total unpredictable chaos. If this is all just coherent wave entrainment, why does it look so chaotic?
What's fascinating here is how ODTBT forces a total redefinition of chaos itself. In this framework, chaos is not randomness. It is not an absence of order or a breakdown of the laws of physics.
What is it then?
Chaos is simply unresolved field interference, or, to use Surmont's terminology, it is transductive coherence without stabilizing closure.
What does that mean, practically?
It means the system is still perfectly mathematically coherent within the full 12-dimensional oscillatory structure. The math in the substrate is working perfectly. But when we project that incredibly complex 12-dimensional phase interaction down into our limited classical 3D coordinate system, our cave wall, the shadow looks erratic. The projection loses the deeper stabilizing geometry. We call it chaos because we are blind to the higher dimensions where the order resides.
Because we are only seeing the chaotic shadow of the interference. It's like looking at the tangled roots of a tree from underground and thinking it's a random mess, because you can't see the perfectly symmetrical branches above ground.
That is a perfect metaphor, and this is exactly where the twist boundary comes back into play on a macroscopic scale.
Right?
When three massive holonic oscillators are interacting, they're constantly generating phase strain. Tension builds up in the topology of the field. The system looks chaotic and unstable to us until the phase tension reaches a critical mathematical threshold.
And then it snaps.
Yes, a twist event occurs. The entire system discontinuously reorganizes to resolve the accumulated tension. It violently shifts its phase alignment and falls into a new, stable phase attractor. One star is ejected, and the remaining two settle into a binary orbit. It isn't random. It isn't a failure of physics. It's just the universe operating on a topological scale and in a dimensionality that classical shadow-based physics was simply never built to map.
So what does this all mean? We've spent the last hour breaking reality down.
We really have.
If mass, gravity, space-time, the orbit of planets, if everything we consider real is actually just a phase alignment,
Yeah.
if we are just living inside the shadows cast by a recursive 12-dimensional field, does that mean we can manipulate the projector? Can we change the shadows on the wall by figuring out how to hack the fire?
That is the ultimate technological question, and it leads us directly into a fascinating section of the papers that takes all of this mind-bending, abstract theoretical geometry and points it straight at the future of human aerospace engineering.
Aerospace engineering.
Yes, Surmont applies the ODTBT framework to analyze a set of infamous, real-world documents known as the DIRDs.
For the listeners who aren't deep into government aerospace lore, the DRDs are the Defense Intelligence Reference Documents. These were a series of papers commissioned by the U.S. government to survey highly speculative fringe aerospace concepts.
Right.
We're talking about warp drives, traversable wormholes, zero-point energy extraction, advanced metamaterials. Traditionally, mainstream physicists look at the DRDs and laugh.
They do.
They say these concepts are mathematically impossible because they require things like negative mass, or they violently break the relativistic tensors of Einstein's spacetime.
Right. They're generally considered the realm of pure science fiction. But Surmont takes these DRD concepts and runs them through the ODTBT framework, specifically utilizing a highly advanced simulation engine called RSIM v4.0.
Okay.
And suddenly, when viewed through the lens of a 12-dimensional oscillatory substrate, the impossible becomes simulatable.
How does a warp drive suddenly work?
Because ODTBT completely changes the grammatical rules of the engineering problem. If you want to build a warp drive in standard physics, you are trying to physically bend a rigid space-time manifold using exotic, impossible matter.
Right.
It's like trying to bend a steel beam with your bare hands. But in ODTBT, space isn't a rigid manifold, it's a field. So you aren't bending steel. Instead, you are technologically modulating the recursive curvature memory, or RCR, and you are actively adjusting the phase strain. You are manipulating what the paper calls the ZDV0 topology.
You're hacking the graphics card. You aren't violating classical physics. You are just writing a new line of code that triggers a localized scalar emergence event. You're telling the substrate to draw the shadow differently.
Exactly. It transforms these fringe concepts from theoretical possibility literature into actual mathematical scalar topological design.
Yeah.
Let's take another example from the DRDs, zero-point energy. The idea of extracting limitless power from an empty vacuum. In classical physics, extracting energy from nothing makes zero sense. But ODTBT doesn't see a vacuum as empty. It sees the vacuum as a boiling sea of unmanifested codon latency.
Codon latency, what does that mean?
Think of a guitar string pulled incredibly tight, but perfectly still. It isn't making a sound, but it contains massive latent energy.
Right.
In ODTBT, you don't extract energy from nothing. You use specific field entrainment to pluck the latent topological string in the substrate. You access the locked energy via resonance. The framework even maps out the physics for cognitive interfaces, the science fiction idea of a pilot controlling an advanced craft entirely with their mind.
How does the math explain telepathy with a spaceship?
By modeling consciousness not as a mystical aura, but as a highly structured, localized oscillatory field. Controlling a craft becomes an exercise in neurofield entrainment, governed by dual codon bifurcation.
Okay.
The pilot's neural field achieves phase resonance with the craft's propulsion field. They become a single merged holonic oscillator.
My brain is officially melting, but I have to play the skeptic again. This all sounds amazing on a computer simulation running RCSim v4.0. But engineering requires physical proof.
It does.
Is there any way to prove that these topological field manipulations actually happen in the real physical world and aren't just artifacts of a simulation engine?
Surmont anticipates that exact criticism. And to prove that this isn't just a purely theoretical sandbox, the text heavily leans on a very real, very physical branch of science called Cymatics. Specifically, the Chladni plate test.
Oh, I have seen videos of these. For the listener, a Chladni plate experiment is mesmerizing.
It's beautiful.
You take a thin, flat metal plate, cover it evenly with a layer of fine sand, and then you either run a violin bow across the edge of the plate or you hook the center of the plate up to an audio speaker.
Right.
As you pump different sound frequencies into the plate, it vibrates, and the sand starts violently jumping around.
Yeah.
But it doesn't just scatter randomly.
No, it forms patterns.
Suddenly, the sand snaps into these perfectly symmetrical, incredibly complex geometric patterns, mandalas of sand.
Yes. And the pattern changes instantaneously the moment you change the audio frequency. In the context of ODTBT, a Chladni plate driven at a resonant frequency is a perfectly controlled tabletop Plato's cave.
Oh my God.
The metal plate itself is the cave wall. The invisible acoustic driving frequency pumping through the speaker is the fire.
Wow.
And the geometric sand pattern that magically emerges on the surface. That is the shadow. It is a literal physical 2D projection of a 5D acoustic field geometry interacting with the boundaries of the plate.
That is such a powerful, intuitive image. The sand is the visible universe. The sound is the substrate.
It is exactly that. And the ODTBT framework predicts something very specific. It suggests that if you drive the Chladni plate not with a standard mundane Maxwellian frequency, but with a highly specific coherence-gated non-Maxwellian signal, what the papers refer to as protocol S or protocol T, you will witness what is called mode selection bias.
What happens then?
The sand patterns will shift in highly specific, mathematically predictable ways that reveal the underlying singlet or triplet channels of the 5D state.
So by carefully altering the frequencies, by hacking the fire, the researchers can effectively simulate walking up to the chained prisoner in the cave, grabbing their head, and turning it just a fraction of an inch, allowing them to finally observe the true signatures of the 12-dimensional substrate projecting the universe.
Precisely. They're using sound and sand to prove the 12-dimensional architecture of reality.
I feel like I need a nap and maybe a degree in advanced mathematics. We have covered an absolutely unbelievable amount of ground today.
We really have.
We've taken you, the listener, on a journey that has fundamentally dismantled the physical world around you. We started by realizing that our universe, everything we can touch, measure, and see, is just a 2D shadow dancing on a cave wall, cast by a staggering 12-dimensional substrate.
Yes.
We looked at how a tiny mathematical anomaly, a near-zero sign value driven by a 3-pi coincidence, acts as a universal shock absorber, giving particles their mass and allowing our universe to exist.
Incredible.
We solved the famously unsolvable 3-body problem by deleting the concept of solid objects entirely, replacing planets with breathing, phase-locked holonic oscillators in a cosmic bathtub. And we saw how this exact same geometry lays the rigorous mathematical groundwork for simulating warp drives, extracting zero-point energy, and proving it all with vibrating plates of sand.
And the most important takeaway here, the reason this matters beyond academic curiosity, is how deeply this changes our view of everyday reality.
Absolutely.
The ground you are walking on right now, the device you're using to listen to this deep dive, the very cells in your body, and every passing second of time you experience. They are not absolute, rigid facts of a cold, mechanical universe.
They're not.
They are stabilized wave patterns. They are shadows on the wall, cast by an immensely complex, unspeakably beautiful geometry of phase coherence that exists just outside our biological ability to directly perceive it.
That maybe not outside our ability forever,
Great.
because there is one final piece of this puzzle that I can't stop thinking about.
What's that?
In the ODTBT framework, the 9th dimension of that 12-dimensional reality is omegar, the observer phase alignment, the mathematical variable that represents the chains in Plato's cave.
Right.
This dimension dictates exactly how much of the true reality is visible to the observer. The observer isn't separate from the physics. The observer is baked into dimension number 9.
Yes.
So I want to leave you, the listener, with a thought to mull over. If the physical laws of the universe, the very boundaries of what is possible, literally depend on the phase coherence and the alignment of the observer, what happens to the fabric of our physical reality when human consciousness collectively shifts its alignment?
Oh, wow.
Our way as a species, approaching our own macroscopic twist bifurcation, are we about to reach the threshold of phase strain where we are violently, wonderfully dragged out of the cave?
That is a profound and frankly chilling question to end on. It implies that the evolution of physics and the evolution of the mind are the exact same thing.
Thank you so much for joining us on this deep dive. And the next time you find yourself looking at an X-ray, remember, you're only seeing the shadow of the bone. Until next time.